Today, the Pakistani master received another major task. The current gearbox input shaft is damaged and can no longer be used normally. Originally, he intended to have the master directly repair it. However, the master explained that because the gear teeth are relatively small, directly welding might not be reliable in the long run. Therefore, he and the car owner came to this specialized store selling used parts. The owner of the store is also the master's third uncle and was very enthusiastic. He searched for suitable parts from the shelves. However, there are very few of these input shafts, and after searching for a long time, only one damaged spline shaft was found. Fortunately, there was no problem with the gear teeth on this side. So, the repair master directly stated that these are minor issues, and subsequent processing would be straightforward. When the car owner confirmed the repair, the master was very prompt and had already brought the input shaft into the shop. Although the processing is simple, it is also time-consuming. The repair would only charge 2,000 rupees for labor. Now, the master has started working on the damaged input shaft. To improve the quality after repair, the master needs to employ a delicate technique. First, the master needs to use a lathe tool to cut off the damaged gear teeth. While cutting, even though the gear teeth are very hard and the master is using an ordinary threading tool, the cutting process is still very fast. After a lengthy 2.5 minutes of cutting. Now, the protruding gear teeth have also been cut flat. At this point, the master needs to use calipers to measure the dimensions in order to cut the other end. Because both ends need to be threaded for assembly, the other end also needs to be chamfered before threading to facilitate installation. Before cutting the threads, marking pens are used here to mark the area for observation of the threading process. Once marked, the master can proceed to cut the threads needed for joining. Unlike the standard threading process that requires specific pitch, the master only needs to rely on experience and cut in the most flexible manner. After the threads are cut, the master needs to use a countersink tool to polish any excess burrs. Once polished, the master can then proceed to cut the other section. Because this section only requires the use of the intact teeth at the head, the master only needs to use a milling cutter to cut down the front teeth in one go. In this process, with the master's skilled cutting, the teeth are successfully trimmed. Although they have been cut down now, the inner diameter of the teeth is still far from the required size. Next, the master will continue to use the milling cutter for detailed cutting, comparing the size with the other end and continuing until it's appropriate. In this cutting process, with the master's adeptness, the inner diameter of the teeth has been swiftly and accurately cut. To facilitate the subsequent assembly, the head also needs to be cut, and the inner surface needs to be marked with a marking pen for observing the pitch. The internal threads, after being trimmed by the master's precise cutting techniques, were quickly and effectively cut. To facilitate the assembly, the master applied lubricating oil for lubrication before joining. Just as the thread cutting was done excellently, the joining process was also straightforward. After the trimming, only the two ends were available for welding and fixation. Thus, the other side of the teeth also needed to be chamfered. Once this was done, the two ends could be joined together. For the chamfered ends, the master could then proceed with the welding process using an arc welder at the designated chamfer positions. Even though the chamfers weren't particularly large, under the master's skilled welding, the process was completed swiftly. Due to the unevenness of the welding areas, the master then used a lathe tool to smoothen the surface. This step was relatively simple and, with the master's adept handling. Regarding the master's repair skills, how would everyone rate them on a scale of 10?
You may not believe it. In a simple workshop, they are able to produce truck wheels that would take millions of production lines to produce. Although this production method is still in the Industry 1.0 era, in many places it has been lost for a long time. Relying on the ancient craftsmanship, the steel wheels are popular among truck drivers. Compared to aluminum wheels, these steel wheels are very strong. More importantly, it is economical and practical. At a good price, just 2,000 rupees each. The master first takes out the cut steel plate and rolls it to form a cylinder. The welder fixes the joints. In order to ensure its structural strength, the joints are welded on both sides. You can see from the welds, the master is at least a grade 8 welder. The rim is welded to form the initial shape of the wheel hub. The workers then processed the welds. They didn't grind the welds flat. Instead, they used high temperature heating. After heating the weld to 1000 degrees, and put it on a rolling machine. After rolling, the original raised weld is pressed into a flat surface. This makes the weld flat and guarantees the strength of the weld. Then we come to an important part of the wheel machining. The master puts sets the rim on the special stand, and put down the fixture on it. The machine is started after it is clamped and fixed, rolling and shaping the waist of the rim through the mold. Under the skillful operation of the workers, the waist of the rim is outlined with a beautiful waistline. Then the clamps are released, and put a piece of ring cushion, reclamping and fixing. The second rolling is done. As the rim rotates, a step structure is slowly formed. I have to say, it's a simple approach. It's an aesthetic of mechanical power. Now the wheel structure has been formed. The last piece of the puzzle is still missing, the rim that holds the wheel in place. This square steel plate is the material used to make the rim. A hole is pressed into the center of the plate. The four corners are partially cut off, from sharp corners to rounded corners with curves. The rest of the operation is done on this press. 3 small holes are pressed into the plate to dissipate heat. Each straight edge has to be cut, to form an inner arc in the opposite direction of the rounded corners. So everything is ready. The worker changes the mold, and presses the iron plate into shape, from a flat surface to a 3-dimensional structure. The molding is complete. The structural framework of the wheel circle has been shaped. The worker inserts a hole punching mold into the hole in the center, and puts it on the drilling machine. 5 holes are drilled for mounting bolts. The drilled rim is placed in the rim. The rim is leveled by precision instruments. The wheel is welded together to form a single unit. The steel wheel is finished. Would you choose a wheel made in this way?
This is simply unbelievable. The car's outer CV joint, split in half, after a simple repair by the Pakistani master, looks as good as new. This has once again overturned my understanding of repairs. Indeed, in Pakistan, there seems to be no concept of scrap. Any issue that can be solved with a welding lathe is considered minor. First, the master cuts out the damaged section. Next, he brought out an outer CV joint he had collected for many years. The splines and ball bearings in this joint are already damaged. Now, he plans to use a technique akin to grafting and woodworking to piece it together into a complete outer cage. Before joining the pieces, he first removes the severely worn ball bearings from inside and prepares to replace them. Otherwise, there might be abnormal noises when the vehicle turns. After removing all the steel balls, he secures the cage onto the lathe's 3-jaw chuck, making minor adjustments. Then, using a thread cutter, he processes the end face, machining the pin to make it flat and smooth, preparing it for the subsequent tasks. Next, he uses a drill bit to create a center hole in the center of the end face, intended for joining. To ensure a sturdy connection when joining the pieces, the master opts for a threaded joint. After drilling the hole, he then uses a tap to thread the inner hole. Again, using the thread cutter, he chamfers the cross-section, turning a slanted surface to serve as a bevel for the subsequent welding. After cutting, he can screw the bolt into the threaded hole and tighten it with a wrench. Next, using an angle grinder, he cuts off the bolt head, turning it into a threaded rod. The top of the threaded rod still requires some minor processing. On the other end, it can be screwed into the spline section. The spline section undergoes a similar process. First, the end is machined flat with a thread cutter, then it is chamfered. Next, he uses a drill bit to drill a hole in the center. After drilling the hole, he taps it to create threads. Next, they can assemble and weld them together. To ensure they are perfectly aligned, before welding, the master will use a center point to fix them in place. Then, he starts the lathe to check for any wobbling of the workpiece. Once everything looks good, welding can commence. To make the joint more robust, during the welding process, the master will perform the build-up weld in 3 layers. After each layer of welding, he pauses to chip off the welding slag to prevent defects like pinholes and porosity. After completing the welding, the excess welding scars need to be machined flat. After machining, the inside of the ball cage needs to be thoroughly cleaned using diesel. The ball bearings of the split ball cage also need to be cleaned. After the ball bearings are cleaned, they can be installed. The master uses a vise to hold the ball cage in place and then apply some grease on it. This ensures that the ball bearings won't easily fall off during installation. After the installation of the ball bearings, they are polished and smoothed using a grinder. After polishing and smoothing, it now looks almost as good as new. However, the job isn't done yet. The master still needs to apply more grease and then reinstall the half shaft. Next, he secures it onto the lathe's chuck and starts the lathe to spin it for inspection. Swinging the half shaft simulates the motion of the ball cage during turns. If there's no rattling sound, it means everything is fine. Next, apply grease once again. After installing the dust cover, you can bring it over to the car side and reinstall it. The installation method of this ball cage is relatively simple, not too complicated. Just 2 nuts. One for the lower arm and one to secure the outer ball cage. When tightening the nut for the outer ball cage, the master uses a specialized tool to lock the flange, preventing it from turning during the tightening process. Next, the tire is reinstalled, and the job is done. Thumbs up for the master's exceptional craftsmanship.